Well, up to quick soil mechanics lessons with Brian. Liquefaction simply explained in 12 acts. In reality, I don't know how many acts there are going to be, so let's just go with it. So Act 2, more circles. So if you remember, we've got our happy little soil element in the ground. There's no core pressure involved in this particular setup because we're looking at total stresses. We've got our vertical and horizontal loads, and we've got our axis with normal stress on the horizontal, shear stress on the vertical, and we can plot sigma v on that axis, and notice there's no shear stresses. We can plot our upper half of the circle, which is a Mohr circle, and our failure envelope, which is defined by the friction angle. And in this case, the circle's not touching the failure envelope. It's not failing. It's just a happy little soil element. And let's take a closer look at that soil element. So we've got our vertical and horizontal load. Well, it's not in balance. Well, actually it is. I just haven't drawn all that. So it's a static problem, and we could have shear stresses as well, but in this case we don't. And if you recall, a principal stress is a normal stress acting on the principal plane that has zero shear stress. So in this case, these are principal stresses. So we can replace sigma v and sigma h with sigma 1 and sigma 3. And you might say, well, what happened to sigma 2? Well, the soil element has a thickness, so sigma 2, the intermediate stress, is in and out of the page. So if we get back to this diagram, we can replace sigma h and sigma v on the element with sigma 1 and sigma 3. And the same thing on the chart, sigma 1, sigma 3. So for most ordinary soil mechanics problems, sigma 2 is equal to sigma 3, so there is no additional Mohr circle. If it was a three-dimensional true triaxial condition, would be a sigma 2, and we'd have an additional Mohr circle. But in our case, we don't. So triaxial shear test, we have our principal stresses, and in an isotropically consolidated triaxial shear test, the test is in compression and the lateral pressure is held constant, the vertical is increased. In reality, it's a hydrostatic pore pressure, so it's equal all around. We represent the principal stresses this way. So let's get back to our diagram here and talk about isotropic consolidation, where sigma 1 is equal to sigma 3, and of course sigma 2 also, and tau, or shear stress, is equal to 0. So we consolidate that. Remember, there's no shear stress. We just come along the x-axis, and we get to the finishing point, which we call the initial confining pressure. Get back to our diagram here. We've got our initial confining stress, where sigma 3 is equal to sigma 1. And remember, we're going to increase sigma 1, the vertical stress, and hold sigma 2 and sigma 3 constant. So we'll look at undrained loading and total stress, which disregards pore pressure, and we're going to start making our Mohr circles. They get larger and larger and larger as we continue to shear, as we continue to put an increased sigma 1. And at some point, it comes to the failure envelope where that test is finished. Now, the reason that I put these videos together, one is for my own entertainment, but two is to maybe make somebody's life a little bit simpler and make it easier for them to explain in very simple terms to somebody else what all of this means. So if you enjoy these, then let somebody else know. And I really enjoy your comments, so don't forget to comment also. And so until next time, we'll call this the end, and see you next time in Act 3.